science and technology for disaster management and mitigation. So when we are talking about this geoinformatics, the major applications are of remote sensing. So to sense from remote means दूर से sense करना. So that is with the use of satellite, and this satellite, they are continuously capturing the images of various objects on the earth surface. Second is application of GIS, that is geographical information system. So basically it is the integrated system of data, application, people, and hardware, software, etc. So everything is included and in the actual application form that will be available through GIS. And third one is GPS, geographical, that is global positioning system. So this GPS, that is very useful in locating the particular person or any vehicle that are engaged in disaster management. So first thing that you should know, what is disaster management. So already you are knowing this disaster management. It is having this capacity building component that are called mitigation, preparedness, that are pre-impact, and when any event of disaster takes place, then it will start with the response, and later on that is recovery, that is restoration part. Okay, so this disaster management comprises of all forms of activity, including structural and non-structural measures to avoid. First thing is to avoid means prevention, or to limit by capacity building in the form of mitigation and preparedness of adverse effects of disaster in pre-disaster phase, during disaster phase, as well as post-disaster phase in the form of response, relief, recovery, and reconstruction. So this disaster management includes all these particular activities: mitigation, preparedness, recovery, and response. So conventional tools earlier that we were using for disaster management, there are many issues with that. Okay, so earlier when we are not having that big computers and information technology, not good communication system were not developed. So in that case, they were using maps. Okay, so this conventional maps that has become outdated nowadays. Why? Because they are having the scattered database. अलग-अलग map में अलग-अलग information है. ठीक है? So it is not easy to collect in short time. Short time में उसको collect करो, उसको इकट्ठा करो, and to make it applicable for the management of disaster, it was very difficult. अलग-अलग डेटा अलग-अलग जगह मैप के that hard copy के फॉर्म में स्टोर किया हुआ है. So it is not easy for that. Then difficulty in assessing the damage. So if some damage has taken place, you cannot assess with the help of that outdated maps. Also, it is difficult in getting an overview of situation. Situation क्या हो रहा है, that you cannot visualize with the help of those conventional tools. Also, difficulty in sharing the data. If you are having hard copy, then it is very difficult to share the data. So similarly, all the old tools that earlier they were using, they are having all the major issues related to management of disaster. Now it has come up the geoinformatics. So what is this geoinformatics? It is the science and technology which develops and uses the information science infrastructure to address the problems of geography. So geography, that is related to our earth. Then cartography, that is nothing but it is the science and technology which is related to map. Okay, so easily in the form of soft copy you can store it. Okay, then geoscience and related branches of science and engineering. So major thing is that we have to utilize science and technology, and major part is of creation of maps and information about earth. Okay, so this geoinformatic technologies used in DEM particularly are remote sensing, geographic information system, and global positioning system. And also the science and technology, they are also very much useful because it consists of information technology. Without that you cannot imagine. And communication technology, this communication is very important whenever we are dealing with management of disaster. So this also you have to learn in detail: information technology and communication technology. So major geoinformatics application in disaster management. So all three phases that can be taken care with the help of this geoinformatics application. So first, pre-disaster. So when we are talking about pre-disaster phase, means it is related to capacity building. So capacity building means we have to more focus on prevention, mitigation, and preparedness aspect. So this HRV mapping, that is hazard mapping, then risk assessment and vulnerability analysis of any area, that can be done with the help of this geoinformatics application. रिमोट सेंसिंग से, GIS से, GPS से आप ये सब कर सकते हैं. Then preparedness plan. So this preparedness plan always you can prepare based on this application of data of science and technology. Then early warning system. This early warning system and monitoring system that can be designed based on this geoinformatics, remote sensing, GIS, major application. Then risk modeling. So everything that is necessary for capacity building in pre-disaster phase, in that case geoinformatics can help. Next is during disaster. So whenever any disaster take place, then public warning system, that is to be made applicable. Then emergency operation is to be carried out. So during this emergency operation, there is a more role of GPS. Okay, search and rescue operation, evacuation planning. So evacuation planning you can do with the help of satellite imageries. If you are having satellite imageries कि कौन से एरिया में ज़्यादा डैमेज हो गया है, so कैसे रूट डिसाइड करना है. So everything that can be done. Then distribution of relief, etc. Okay, so which area is more affected, that can be easily known to you. So post disaster, whatever this damage assessment that you have carried out, that can be useful after disaster. Then temporary shelter कहाँ पे बना सकते हैं. Then claims processing, grants and reconstruction. So all these three phases in which you can apply your geoinformatics. So now we are talking about this remote sensing. So it is consisting of these satellites. So these satellites that are moving far away. So remote means far away. Far away से sense करना. That is the simple meaning of remote sensing. So it acquires the data about an object without touching it. You don't have to go there. Okay, these satellites that are installed with a very high resolution loaded camera that are capturing the images of the different objects on the Earth's surface. Okay, so such measurement require a medium of interaction. Abhi, whenever such cameras are installed, they need some medium of interaction, and this medium of interaction is the electromagnetic radiation. So this electromagnetic radiation, which is either reflected or emitted from the object, that is the usual source of remote sensing data, because each object on the Earth's surface, they are having different reflective or light emitting properties, and these property differ themselves. तो हर कोई इमेज जो भी कैप्चर होता है वो एक दूसरे से अलग दिखता है. So that can be used as a base for separating all these images. So this remote sensing, so if you have to define this remote sensing is the science and art of obtaining information about an area, object or phenomenon through the analysis of data acquired by the device that is not in contact with the area, object or phenomena under investigation. You don't have to go there just by capturing the image, and that image basically जैसे हम फोटोग्राफ खींचते हैं ऐसे इमेज नहीं आ जाएंगे directly, but it will be in the different form. That data you have to acquire, then you have to analyze them. So proper analysis has to be done, and that can be done by the person who is involved in that particular reading aspect. Okay. So next is GIS. So first we will discuss all this, what is RS, what is GIS and what is GPS. Then after we will go in detail one by one. So this GIS is a very powerful tool. So GIS is a system of hardware. It involves hardware, software and data. So this data that can be obtained in the form of satellite imageries. Apart from that, different data, that is ground data जो हम actual data बोलते हैं, वो भी उनको they have to collect everything. So many data gathering is to be done, and all the data in the form of layers that can be applied, and personals to efficiently capture, store, update, manipulate, analyze and display all the forms of geographically referenced information. So all the information जो भी हमने इकट्ठा किया है सब का application you can have in the form of layers. आपके पास population के data है, आपके पास that image is there, then ground water के data है, crop data, so many data. So data integration is the major capability of this GIS. So it comprises of hardware, software, data. So data integration, that is the major strength of this GIS, Geographical Information System. And people and application or procedure. And third one is GPS. So it is the network of satellites. So it is nothing but it is the network of satellites that continuously transmit the coded information. Continuously coded information transfer करता रहेगा, which makes it possible with the help of an instrument, which may be hand-handled or vehicle पे instrument, to precisely identify the location on the Earth by measuring the distance from the satellite. Satellite से आपका कितना distance है उसके हिसाब से जो भी आपका user है उसका आपको continuously you can locate them. Okay, so you can identify their location on the Earth. So this is very important application that can be useful in management of disaster, and particularly in case of during disaster, that is response phase, and early warning maybe that can be very useful. So that we will discuss in detail. So first we'll discuss what it is, how this remote sensing that can be useful for managing disaster. So this remote sensing means understanding the physical basis of signatures of object captured within the satellite picture. So satellite picture, that is called as the satellite imageries. So basically on the Earth surface different objects are there. Okay, so that need the medium of interaction, that is called as your electromagnetic spectrum. So these high-speed loaded computers with the remote sensing software and their characteristic spectral signature. Now, how they are capturing the data and how it is differing from each other. So for that, this remote sensing data are acquired in the predetermined spectral band. So it can be differed by wavelength. So generally it is visible and near infrared spectrum band that are generally chosen to amplify on the separate specific Earth features such as vegetation, rock, urban area, then snow, water. So generally what happens, this all land features, they are differ to each other by the choice of the wavelength. So just try to understand here the spectral signature, because this is the major base behind the capturing of image. Now sun's radiation, so this sun's radiation, it is falling on all the objects, sub objects हैं आपके different objects, okay, and part of the radiation it is absorbed. So each object, they are having different capability to absorb that, at the same time they are having different capability to reflect them. So part of it will be reflected with different wavelength. So each object, here you can see this is water, this is some object, now here the reflection from this industry in the form of emission. So all are absorbing, all are reflecting, but their capability or their what you can say, it's reflectance and absorbance, it would be different. So that will make them differentiable when these sensors, they capture the image. So this body of the Earth, like soil, vegetation and water bodies, have different characteristics of reflectance and absorption, so which make them differentiable on satellite imageries, and that is what which is called as spectral signature. So each and every object of the Earth surface, they are having different spectral signature. सबका spectral signature अलग-अलग है, तो वो सब differentiable हो जाएंगे on the satellite imageries. Okay, so after analysis, you can make out okay, this area, this is water part, this is crop part, this is emitted toxic gases area. So that is decided based on this reflectance. So this satellite data, all this radiation which is coming, so here you can say it's a paved road, this is built up area, this is grass, this is water. So all are absorbing certain radiation and also reflecting certain radiation. So that reflected rays, reflected solar radiation, that can be captured with the help of that satellite in the form of satellite imageries, or sub different दिखेंगे. Okay, so here this is a complete sequence. Sunlight, incoming radiation, all are emitting, but their signature would be different, so they will be differentiable on the satellite. So through this antenna receiver, that is transferred to ground station, then computer analyst, they will work on that. everything they have got in the form of satellite imageries, but they have to analyze it properly and then you can apply it. So here there is a role of GIS. Whatever satellite imageries that you are having, that can be made in useful form, जो आपको पता चल सके यहाँ पे क्या है. Okay, so initially when data comes up, we cannot make out that which area, or here there is a water or here there is a crop, we cannot make out. But after this analysis and it should be done in the form of application, and then exactly you can visualize everything. So there are two types of remote sensing. First is active remote. So basically it all about the sensors, whatever the satellite, which kind of sensors they are having. So this active sensor have its own source of light. So here there is no need of sunlight. Without sunlight also they are using their own light of illumination, and the sensor measures the reflectance energy. So here there is no need of sunlight energy. So here this the light which is coming from the sensor itself. So that's why it's called as active sensor. Then reflected light, it can be captured in the form of satellite imageries. So these active sensor examples are Canadian Space Agency's RadarSat 2. Then so many sensors that they are having their own source of light or illumination. So they don't need sunlight. But second is passive remote sensing. So here they are not having that particular light source. So they have to utilize the this solar radiation that is coming on the different objects, and then depending upon their different reflectance, their satellite imageries can be captured. So these passive sensors, they measure the reflected sunlight only, which is emitted from the sun. So now this remote sensing technology, this has become very useful nowadays. So this Earth observation system, it is called as the Earth observation system using satellite. Okay, this it has made it possible to obtain the uniform data covering the whole globe. Kahin pe bhi this satellite, they are just tracking everything, and in the relatively short time, and also it has made it possible for this observation to be continued for a long time in future. So this concept of remote sensing, it is widely used all over the world, and this remote sensing, it has major application in management of disaster. And now due to improvement in all the this resolution, etc., it is nowadays becoming more and more useful, particularly for disaster management. So when we are talking about this space-based technology, then of this Earth observation system, there are two types of satellite which are widely used. Okay, so there are two main components of the space-based subsystem of EOS, that is Earth observing system. So first is geostationary satellites. So these are widely used, and second is polar orbiting satellite. This. So it is both are continue to improve with every new launch. जितने जितने नए launch होते जाते हैं, उनका resolution and their applications, they are becoming more and more useful. So first is geostationary satellite. So a geostationary satellite is an Earth orbiting satellite placed at an altitude of approximately 35,800 kilometers. So it's far away, and directly over the equator, that revolves in the same direction the Earth rotates, west to east. So you can say that it is very far, okay, and that is generally orbiting directly over the equator, and it also revolves in the same direction as the Earth rotates. जैसे अर्थ रोटेट कर रहा है, उसके साथ साथ एक जियोस्टेशनरी सैटेलाइट भी साथ में ही चल रहा है, okay, with the same speed. So what happens? It will capture the image, but as it is also orbiting, Earth is also orbiting, so both every time it is capturing the same image. तो वहाँ पे अगर कोई भी changes हो रहा है with respect to time, that can be observed. So it is not changing the place; it is capturing the same image, okay, because it is also revolving along with the Earth. So they observe the same point. That is the thing. it observes the same point on the Earth continuously, but from a very higher altitude. So that higher altitude is 36,000 kilometer approximately. So these geostationary satellites are the primary meteorological observation platforms. Meteorological related जितने भी आपका phenomenon है, that are all captured in very minute detail that you can observe, provide continuous but somewhat coarser spatial detail. Coarser means इसका resolution इतना high नहीं होगा because it is capturing the images from very high altitude. But all the meteorological observation platforms जितना भी information है that can be obtained with the help of this satellite imagery of geostationary satellites. So okay, here you can just try to understand this. So this is your Earth. Okay, so here this is the satellite, and this is at the approximate distance of 36,000. So here it is the path. Okay, so here you can see it is moving along with the equator. Okay, and also it is orbiting along with this Earth. Earth is also orbiting, and our satellite is also orbiting. So ये भी मूव कर रहा है, ये भी मूव कर रहा है, तो एक ही पोजीशन पे, बट बहुत बड़ा एरिया कवर करेगा बिकॉज इट इज वॉचिंग फ्रॉम ए वेरी फार डिस्टेंस. सो दिस इज कॉल्ड एज द जियोस्टेशनरी ऑर्बिट. ओके, so this NOAA, that is nothing but National Oceanic and Atmospheric Administration, that is by USA. They are having these two satellites, which is called as GOES, that is Geostationary Operational Environmental Satellite, and also this East Coast, that is called as a GOES East, and also GOES West. They are all continuously tracking very wider area. Okay, and next is polar orbiting satellite. So here just try to understand what is polar orbiting satellite. So polar orbit is one in which the satellite passes above or nearly above both the poles. Okay, so North Pole and South Pole. So they are passing above or nearly above both the poles of the body, being orbited on each revolution. So continuously it is revolving, or it is orbiting these poles. So its path is like this. So it is passing through this poles, North Pole and South Pole. So polar satellites, also known as the sun synchronous satellite, they orbit about the Earth's surface at around 715 kilometers. So you can just see the difference of kilometer. Here it is around 715 kilometers. And this polar satellite, they monitor the strong storms that move across the poles. So pole के पास जितने भी जो strong that storms that are coming, that are generally captured by this polar orbiting satellite. Okay. So generally fly in low Earth orbit, so hundreds of kilometers. Here it is around 715 kilometers, and provide relatively high resolution because its distance is less. So you can see all the details very minutely as compared to that geostationary satellite. Geostationary satellite, the coverage area would be larger, but the resolution would be lesser. But here, the coverage area would be less, but resolution would be high. And with the repeat times of the day, that is repeat time means the different because it is continuously moving, it is capturing the image. So this repeat time, एक object को वापस कितने दिनों बाद वापस repeatedly it is capturing. So this that is called as the repeat time. So this repeat time of the maybe of the days to tens of the days. एक दिन के बाद भी वो capture कर सकता है वापस या 10 days के बाद. So typical polar orbiting satellites are NOAA, that is National Ocean and Atmospheric Administration, that is Advanced Very High Resolution Radiometer, that is generally of USA. Basically, all the government, they are generally doing agreements with each other so that whatever images which are captured, that can be utilized by all. Okay, so it's not like each and every country they have to continuously go on launching the satellites. Okay, so they can take the data whatever captured by this. So NOAA, this is widely used. Then French, that is SPOT, and US Landsat and TN series. These are all the typical polar orbiting satellite. And the data received from this polar orbiting satellite is very useful in understanding the monitoring the natural hazards. All the natural hazards, for that data can be useful. and useful to know the effect of the space and time distribution of water. So how the changes in the water that is taking place, because if some global climate change has taken place, how this melting of glaciers and the water level change, which area is now going to inundate, that is सबमर्ज हो जाएगा क्योंकि बहुत सारा मेल्टिंग ऑफ ग्लेशियर हो रहा है, कहाँ पे पानी का लेवल बढ़ रहा है. So everything that can be monitored properly. This energy budget at the Earth's surface from the point of view of understanding the control of mechanism of environmental changes. So all the environmental changes that can be effectively taken in the form of satellite imageries, and that can be better evaluated with the satellite data. So here these two types of satellites which are widely used: geostationary, far away, that is around 36,000 kilometers, and polar orbiting satellite, that is near distance around hundreds of the kilometer. Both are useful in taking all the satellite imageries, and that can be useful for disaster management. So these remote sensing data are acquired in predetermined spectral band. As I have told you, the predetermined spectral band or wavelength is very important. So generally in the remote sensing, so all of you are knowing this electromagnetic spectrum band, writing from this alpha, gamma, this X-rays and ultraviolet rays, near and mid. So this is the range, and this is the visible range. So this remote sensing data that are generally using this visible, near and mid infrared, thermal infrared and microwave position of the spectrum that are widely used in remote sensing. Okay, so you can say it is from here to here, this data that can be widely used. So this, most of the objects that are having this reflectance characteristics in this particular range of visible to this microwave. So this optical infrared region that is consisting of visible, near infrared. So here these are all the wavelength ranges. Okay, that is short wave infrared, mid wave infrared, long wave infrared, etc. So this is the region which is widely used. So how the data looks? अगर आपको ऐसा लगे कि भाई satellite imagery से data लिया तो वो कैसे दिखेगा? So here you can see this you cannot make out anything. समझ में नहीं आ रहा है कि क्या है, सब रेड दिख रहा है. So typically this satellite data which are developed as an FCC. FCC is called as false color composite. So what is false color composite? They are the representation of multispectral image. So बहुत सारी images आ गई है, तो multispectral images because all are having different reflectance and different wavelength range. So using any bands other than visible red, green and blue, because these are the one which we can see, but they are capturing as red, green and blue component of the display. So this false color composite allows us to visualize the wavelength that the human eye cannot see. So in the near infrared and beyond. So generally, initially this is capturing which cannot be made out by the human eye. So after that particularly working on that images, that could be made in the form which can be useful to us. So initially it is coming in the form of false color composite which cannot make out by human eye. So here just see two Landsat satellite images which are showing the same region, that is Chesapeake Bay, that is in city of Baltimore. So here it is a false color composite. Okay, so the same area is shown in the image as a false color composite using the near infrared red and green spectral bands mapped in RGB, that is red, green, blue. And this image shows the vegetation in red tone, as vegetation reflects most light in the near infrared region. So to make this false color composite to the usable form, all the analysis and interpretation and some techniques are to be applied, so that exactly what is there that can be seen in a visible form. So initially FCC to visible form is to be converted. So these are some of the details of Landsat TM band RS data images. So how this actual data on how this false color composite looks, that is just shown in the figure. So agencies which are receiving and distributing the data from the satellites. So these are all, as I told you, that they are all related to each other, and they are all disseminating the data, those that are taken by them, but that that MOU etc. that they have to sign. So that is RadarSat International, that is of Canada, then Canada Center for Remote Sensing, then Center for Remote Imaging Sensing and Processing, Singapore, then EROS, that is Earth Resource Observation and Science Data Center, USA, then Space Imaging, that is of again USA, then Spot Imaging, that is of France. And in India, we are having this National Remote Sensing Agency, India. So here all these are the agencies which are receiving and distributing the data from their launched satellite. Okay, so if someone demands, they can take data from them. So what are the advantages of remote sensing? Repetitive, एक ही जगह का बार बार आपको पता चलेगा क्या changes are there. So changes, so the global climate change that we are calling nowadays. So that we come to know why, because this is a repetitive data and a continuous acquisition of the data. Continuously acquire कर रहे हैं data को. That is repetitive and continuous. And wide region can be covered. So wide area that can be covered by changing the distance and then resolution of the camera. Relatively large area can be monitored with same economy and time. That is very important. Large area can be monitored. Accurate compared to traditional data acquisition, mapping and surveying. कहाँ जाके हम सर्वे करेंगे इतना सारा. So instead of that, if you are having satellite imagery, combine it with the ground data. Ground पे survey करो. Combine it and make it in a more useful form. So this is very important. So applications of remote sensing for integrated uses of data. So many data collection that can be done by this RS. So mapping of vegetation types, coverage, complete types and coverage, कहाँ पे कितने average में कहाँ पे vegetation है, कहाँ कम हो रहा है, everything can be known. Soil type, and their map, monitoring water bodies, mapping the land use categories. On just by the satellite imageries, they will come to know that कि कौन सा एरिया में कौन सा लैंड यूज हो रहा है, कहाँ पे एग्रीकल्चर के लिए यूज हो रहा है, कहाँ पे इंडस्ट्रियल एरिया ज़्यादा है, कहीं कहाँ पे रेसिडेंशियल एरिया ज़्यादा है. So everything that can be monitored so accurately. All the natural disaster that can be assessed, landslide, volcano, everything. Targeting the groundwater occurrence. Also it is useful for knowing the groundwater occurrence and its availability, mapping the flood and flood plains, rock structure, rock lithologies, then landscape units, mapping recharge and discharge area, then watershed characteristics, जान सकते, groundwater, mapping of groundwater vulnerability, risk zone you can identify, selection of the landfill site for the disposal purpose, monitoring of waterlogged area, कहाँ पे ज़्यादा पानी आ गया, soil की salinity. So these are all very much differentiable on the satellite imageries due to their spectral signatures. Assessment of groundwater, irrigated area, disaster management is very important aspect of that. So we'll just talk about this disaster management and remote sensing, just a historical aspect. So it is seen that about 95% of the natural disaster related deaths occur in developing world. So it is very essential for the developing world that we have to control or we have to properly manage the disaster. So most of the people, they are liable to be affected, that is by the natural disaster, and loss of as much as 80% of the gross national product, that is lost. In India also, this natural calamities, they have taken lives of about 1.6 million people since 1960 and caused over around $16 billion loss due to all the different natural disaster. Okay, so major is flood, cyclone, drought, earthquake, etc. So in a number of countries, so it is observed that in those countries where this warning system and building codes, they are more advanced, remote sensing of the earth has been found successful to predict the occurrence of the disastrous phenomena. So this application of remote sensing जहाँ पे apply किया, because 1970s से ये developed countries है तो already apply करना start कर दिया था. So then after this, developing countries like India and others, they are also now applying. Okay, so it is observed that where this warning system, building codes are properly followed, and the use of this remote sensing, it has found successful in predicting the occurrence of the disastrous phenomena and to warn the people in time, and that could save the life of the people as well as the property. So the first Earth resources satellite that was launched in 1972, that was called Landsat 1. So today, so we are far away from 1972. काफी साल हो गए. So today there is an improved spatial as well as temporal resolution. Spatial with respect to space means कितना एरिया कवर कर सकते हैं. Temporal means with respect to time. कितने टाइम में आप वापस वो कैप्चर करते हो एरिया? 10 दिन में, 1 दिन में. So that resolution has improved nowadays, and it provides the unique information about the properties of surface or shallow layer, topsoil of the earth. So everything can be captured. So the impact of natural disaster can be reduced through a proper disaster management, including disaster prevention. So hazard and risk assessment, land use planning कर सकते हैं, legislation बना सकते हैं, building code, disaster preparedness, that is forecasting, warning, prediction, and rapid and adequate disaster relief. So these are all can be done properly. So mitigation of natural disaster can be successful only when this adequate knowledge is obtained about the expected frequency, character, and magnitude of the hazardous event. जब हमको फ्रीक्वेंसी पता होगी कितने सालों बाद आ रहा है, उसका कैरेक्टर पता होगा, उसका मैग्नीट्यूड पता होगा, then we can easily manage it. So each satellite has their different repeat pass frequency and spatial resolution. So each satellite, depending upon their sensors, उसका खुद का कितना फ्रीक्वेंसी कितने दिनों बाद वो वापस लेगा, कितना स्पेशियल रेजोल्यूशन मींस कितना वाइड एरिया कवरेज करेगा, they are all different. Similarly, different satellites have different types of sensors on board, such as panchromatic. These are just the name: multispectral, infrared, thermal. अभी जो पर्टिकुलर सेंसर्स लगे होंगे उसी का वो कैप्चर कर पाएगा इमेज, सब कुछ नहीं कर पाएगा. ओके, सो विच एरिया यू वांट टू कवर, अकॉर्डिंगली यू हैव टू सेलेक्ट इट. All these sensors have applications in the disaster mitigation, and though this depending upon the electromagnetic characteristics of the object on the earth and nature of the disaster relief. But different satellite and different sensors, they are used for different natural disaster. For example, thermal sensors hai. So if some satellite, they are loaded with thermal sensors, they can capture the fire hazards effectively. If they are having infrared sensors, they are more suitable for the flood. If microwave sensors are there, they can record the soil moisture. So several kinds of disasters such as earthquake, volcano, tsunami, forest fire, hurricane, and floods, they are considered for the purpose of disaster management. So particularly earlier what happens, mainly the satellite were used for communication purpose. Okay, but nowadays special satellites that are having main aim for disaster management is also launched. So however, flood phenomena, अगर flood phenomena की बात करें, apart from this remote sensing, there is a wide application of GIS also. Okay, because we have to predict the flood. Forecasting you can do, but prediction of the flood, that can be done with the help of some modeling only. Okay, so it's a combination. It's not always like only remote sensing. It is having the combination of remote sensing plus GIS, and that is more observed in case of the flood phenomena. So these are the major applications of remote sensing for disaster management. To monitor the situation, very important. Continuously you can monitor by taking the satellite imageries. Simulate the complicated natural phenomena as accurately as possible and come up with the better prediction model. Prediction कर सकते हैं आप, ठीक है? Then suggest the appropriate contingency plan and prepare the spatial database. पूरा आप database prepare कर सकते हो and you can prepare the plan. Quick assessing severity and impact of damage, because everything is visible. Flooding, earthquake, oil spill or other disaster. So quickly you can assess the severity. कहाँ पे कितना damage, so damage assessment easily can be done. Then planning efficient escape route. So you can from the satellite imageries you can see कि भाई कौन से एरिया में coastal suppose it's a coastal area during the hurricanes. So you can decide कि इस एरिया में तो हरिकेन आगे चलने वाला है तो वहाँ पे शेल्टर मत बनाओ. You can plan the efficient escape route in the other way. Then charting the quickest route for ambulance to reach the victims. So from which area you can reach to particular victim. So that can be also you can make in the form of charts. लोकेटिंग द प्लेसेस फॉर शेल्टर, कहाँ पे शेल्टर बनाया जाए ताकि वो सेकेंडरी डिजास्टर ना हो जाए. कैलकुलेटिंग द पॉपुलेशन डेंसिटी इन द डिजास्टर प्रोन एरिया. So this is also approximately you can calculate, and by field data you can more refine it. Rapidly identifying the hardest hit disaster area just by satellite imageries. You can come to know that this is the worst area. Okay, so where you need all the help in order to provide the early warning of potential disaster, and pre-disaster assessment to facilitate the planning for timely evacuation. Then monitoring reconstruction or rehabilitation after a major disaster. अगर आपने reconstruction rehabilitation work start किया है, so you can monitor it with the help of the satellite imageries. कहाँ तक कितना काम चल रहा है, कितना एरिया में वो हो चुका है. So developing, maintaining or updating the accurate base map. So all the database management, all the base maps, all can be cleared. That can be done with the help of remote sensing. So remote sensing data, when it combines with the other part that is called as the GIS part, then it is having very huge application in terms of managing the disaster. So now in the next class, we will see the application of remote sensing and GIS for each particular disaster. So how it can be useful for flood, how it can be useful for this tsunami, etc. So for the particular disaster, how this RS and GIS combination can be applicable, that we will see in the next class. So this modern technology that we have developed in the form of RS and GIS, that has improved so much that nowadays we are in good condition to manage any disaster. So thank you.